Hello everyone, my name is Tahar and in today's presentation I will be presenting a Bayesian investigation of the structural, electronic and optical properties of double perovskite. In today's presentation we will have an introduction, a computational details, results and discussion, and in the end a conclusion. Despite phenomenal rise in the efficiency of hybrid halide perovskite-based solar cells from 3% to 22% in a time span of few years, the toxicity of lead is one of the greatest challenges for their commercialization. New generation of perovskite materials such as double perovskite was proposed. These materials are inorganic, stable and non-toxic. For that, the current contribution attempts to investigate the electronic bound structure and dielectric function absorption coefficient of the double perovskite materials using FP-LAPW. The simulations were performed using full potential linearized augmented plane wave method based on the DFT as implemented in Y2K package. The exchange and correlation potential is treated by the generalized approximation and the modified approximation of Beck-Johnson. The calculation parameters are as shown. In this figure, it shows total energy as a function of volume and crystal structure of double perovskite. The optimized lattice parameters and the relaxed atomic position of double perovskite were displayed in Table 1. The valence band maximum is located at the high symmetry point L in the Berwyn zone, and the conduction band minimum is located at the X point, showing that the studying materials have an indirect band gap. The valence band is majorly contributed from BR4P along with extensive and mixture of AG4D states. The conduction band is formed from contribution from AG5S and BI4P state mainly. The optical properties are straightly correlated to the electronic band gap of semiconductor, characterizing the interaction of electromagnetic radiation with a material. The dielectric function is as shown, acts as essential part in the exploring the optical properties of a compound. The figure 3 shows the real part of the dielectric function absorption coefficient and the refractive index. The static dielectric coefficient as shown, a destructive refractive index as shown. The absorption value in the order of 10 to the power of 5 in the visible range, including a large part of the visible range. This is important for photovoltaic applications. The DFT simulations of structural, electronic and optical properties of double perovskite have been reported. The GGA-AMBG approach corrects the band gap of double perovskite and confirms the presence of indirect band gap of 2.03 electron volt. The material showed a good absorption in the visible spectrum region. Based on the present work and available results for lead-free double perovskite compound, strong potential utilization is endorsed for optoelectronic and photovoltaic applications. In the end, I thank you for good listening and for following up.